Hi, my name is Monica Klimchuk, and I am a student from Harvard University, and this is a project that we did in collaboration with NASA. So if I can draw your attention here, if we pretend that this is a cloud and it has ice inside. So the way that we want to measure how much ice is inside the cloud is using microwaves. So here I have a demonstration where I have two different microwave frequencies. The red is made with a lower frequency, which means that it has a longer wavelength. If you notice, that means that it can penetrate deeper into the cloud and it can measure how much ice is inside that cloud. Now, the way that NASA is reading this is through a very large satellite, which is essentially the size of a bus. It has this large antenna here that can read those low frequency microwaves. NASA, however, would like to move to a smaller satellite, which would be something this size. This is a CubeSat. Essentially, there would be 6 of these units, and it could fit inside a briefcase. So you're going from bus to briefcase.
And it will be able to measure the same?
Well, it can't, because it can't support the antenna that is required to read those low frequencies. So our project, essentially what it did is it reconstructed the data for those low frequency microwaves using the higher frequency data that we got from this big satellite. So it was able to still predict how much ice is inside the clouds.
And how soon is this ready?
Well, so they do have these satellites, but they're not equipped yet for measuring the weather phenomenon that our project was specifically focusing on, like ice and snow and rainfall. So we did give our data over to NASA, and we'll see what they plan to do with it.
And if we can, can you explain a little bit what's on this poster here? What does it say?
So this poster is basically just showing why our project is so necessary. Ice storms can be fatal, and so you do need to predict how much ice is inside a cloud so you can see if an ice storm is going to happen.
It's not great for the winemakers and stuff.
It's not great for anybody, honestly, to have ice coming down from the sky, right? So that is an example of what an ice cloud would look like. You know, obviously they can just cause billions of dollars in damage. And so this is essentially the remedy here would be to have something like this that could still predict the ice in the clouds. It also will save NASA a lot of money to be able to use something this small as opposed to something the size of a bus.
Could you have a bunch of those around different countries?
Yeah,
what's the idea?
Again, there's 6 of these that are together, but it wouldn't be any bigger than a briefcase. So you could have a few briefcases up in space.
But if they're in low Earth orbit, they will not be stationary, right? So
no.
You need lots of them to cover the whole world?
Exactly. They can orbit around and measure.
Send a few thousands of them?
Yeah.
Is that what you... Can you show what's on the poster behind?
Yes. So this is more from the data science perspective. Essentially, this shows the problem that I've explained, as well as the results. So this right here is the true image of what those frequencies would be giving us. And these are the 4 models that we created. As you can see, this one was probably the best in terms of the shape here and the color. The darker the color, the colder it was measuring. So these are different temperatures. And over here, you can see our errors. So we started with a baseline model from NASA, which is the blue bar, and then these 4 are our 4 models. We were able to lower the error by 50%, actually.
So is this going to potentially revolutionize these kinds of weather predictions?
Yeah, hopefully. Again, so NASA can save some money by sending up the smaller satellites and still be able to predict the weather even better.